Hello everyone. In this session, we want to take a look at the stub zone. But before we look at the stub zone, we want to revise the DNS zone a little bit to show the relation between the other DNS zones and the stub zone. DNS consists of three sections or three parts. Basically, you have the DNS namespace, you have name servers, and you have resolvers. DNS is defined as a tree-structured namespace in which each branch of the tree identifies a domain. In the example that we see here, we have at the top a root domain, which is a dot, which we don't actually write in the DNS address. Then you have your top level domain, which would be your .net, your .com, .org, .gov. And then you have your second level domain, which is a domain that you as a network administrator would create. When you are promoting your server to a domain controller, you're asked to give a name. And you give that name. If you give the name Contoso, well, that will be your second level domain name. And then you might want to create some subdomains. For example, you want to create West domain as a child of Contoso, South domain as a child of Contoso, and East domain as a child of Contoso. So we have the namespace being west.south.east.contoso.com. Now the namespace can be divided into what we call zones. So for the West domain, you can create a zone. For the South domain, you can create a zone. For the East domain and for the Contoso domain. And what the zone does is it collects the resource records. That means the records that contain the host name, the IP address, and other information for that particular zone. So if I create a zone in West domain, it means that this zone will contain only the resource records that pertain to specifically to West domain. So we might have the West zone, the South zone, and the East zone within our namespace. But each portion of that namespace will have a name server, and that server is going to be authoritative for that particular zone. So again, rather than storing all the records for the entire namespace on each DNS server only stores the records for a specific portion of the namespace. And that DNS server within the portion of the namespace is authoritative for the portion of the namespace that corresponds to the record stored on that DNS server. At this point, we want to take a look at the stub zone and see how the stub zone relates to and interact with the other zones. Now, in our scenario here, we said that we have Contoso, which we will call the parent zone. This is the parent domain. Within Contoso, we would have created a West zone, a South zone, and an East zone. So West domain is a child of the Contoso domain. South domain is a child of the Contoso domain, and East is a child of the Contoso domain. So west, south, and east are all children of that domain, and they have zones. Now, the stub zone. The stub zone is used when you want the DNS server hosting the parent zone, which would be Contoso. We would have a DNS server in Contoso, and we want that server to remain aware of the authoritative DNS servers in the child zone. So in West domain, we would have an authoritative DNS server that will be responsible for the resources in that domain. The same thing goes for South, and the same thing goes for East. What the subzone then is used for is to host the names of the authoritative DNS servers within these child domains. So if the subzone for a child zone is hosted on the DNS server for the parent zone, the DNS server hosting the subzone, which will be Contoso, will receive a list of all new authoritative DNS servers for the child zone when it requests an update from the subzone's master server. So this method of updating the DNS server hosting the parent zone maintains again a current list of the authoritative DNS servers for the child zone as they are added and removed. So the stub zone is a copy of a zone that contains only those resource records necessary to identify the authoritative DNS servers for the zone. A subzone can also be used to resolve names between separate DNS namespaces. Let's say we had another company that was an Adatum company. So we had two separate namespaces. We had the Contoso namespace and we have the Adatum namespace. And we might have had these two companies merging together. So a corporate merger would require that DNS servers for the two separate DNS namespaces resolve names for clients in both namespaces. So in this case, you would need a stub zone because remember, the stub zone is going to host all the DNS authoritative servers, all the names of the DNS authoritative servers for both namespaces. So when someone in the Adatum domain needs a record resolved within the Contoso domain, that query is going to go to the stub zone, and the stub zone will say, yes, I know where this record is. I know where it exists. And it will give the authoritative DNS name or server for that particular record. So that can be very useful. If you didn't have the stub zone, you would have to go from server to server. When the query is made, then your query would be forwarded to another DNS server, and that DNS server might say, well, I don't have that record. Let me forward it to another DNS and to another DNS until the record is found. But if you send that query, and that query goes straight to the parent, where the subzone exists, that subzone knows where all the authoritative DNS servers are, and it's able to point you directly to that server. We're going to take a look and see how the stub zone is set up. So we're going to go into DNS, click on Tools DNS, And we want here to just click on forward lookup zone and then right click and say new zone. We have the new zone wizard. So we click next on the welcome to the new zone wizard screen. And here you would have remembered in previous lessons, we would have created primary or Active Directory integrated zones. Now we want to create the stub zone, so we're going to click on stub zone. And the description for the stub zone here, subzone creates a copy of a zone containing what? Only name servers, NS. Also contains what we call the start of authority record and possibly A records. Please note, a server containing a subzone is not authoritative for that zone. We want to click next to continue. And here you have the same thing that we would have had in the Active Directory integrated zone, the scope, the replication scope. And you now have to make a decision here how you want that zone to be replicated. And we're going to leave it at its default to all DNS servers running on domain controllers in this particular domain, adatom.com. We're going to click next. And now you have to give the name of the new zone. So let us call it adatom stub zone. I want to click on next. And remember that the zone name is not the name of the DNS server. I want to click on next. And here you need to specify the DNS servers from which you want to load the zone. So the subzone is loaded by querying the zone master server for the SOA resource record. So we're going to type the address of those master servers. And we're going to use just one address here. Type 172.16.0.1. And we're going to say use the above server to create a local list of master servers. So we're going to click this checkbox. Then we're going to click next. And you have successfully completed the new zone wizard. And you specify the following settings. And we have a stub zone. And we want to click on next. And we have created the stub zone. We're going to cancel this box because we actually want to go and look at the start of authority record. So we're going to click cancel. And we want to go into one of our forward lookup zones. We're going to look at the properties of the zone. So we're going to right click on adatom and we're going to click on properties. And what we want to zero in on is that start of authority record that we talked about in the stub zone. So we just want to look at it and see what it's all about. So we're going to click on start of authority. And again, it's found on the property page of the zone. And it includes, as you see here, a serial number. And DNS uses the serial number to determine when a zone transfer is required. And the DNS service increments the value by 1 each time the zone changes to indicate that the zone is a new version. So other servers performing zone transfer with that server will use this incremental value to determine whether a zone transfer is required. If the value is higher than the remote server's record for the zone, the server will initiate a zone transfer to update the remote server's zone record. And then we have the primary server, and this specifies the host name of the primary master for the selected zone. We also have here the responsible person, and this property specifies the email address of the person responsible for managing the zone. And then we have here the refresh interval, and this value specifies how often servers that host secondary copies of the zone should check the currency of their zone data against the primary zone. And the default, as you see here, is 15 minutes. Then you have the retrial interval, and this value specifies the amount of time that must elapse before a server hosting a secondary copy of the zone retries a connection to the primary zone when a previous connection attempt failed. Expires after. This specifies the period of time that a server hosting a secondary copy of the zone can wait before discarding its secondary data if its zone data has not been refreshed. You have the minimum default time to live, and that value specifies the amount of time that querying servers can cache results returned from this zone. And as you see here, the default is 1 hour. And then the last time to live at the bottom specifies the time to live for the SOA record itself. And the default is 1 hour. In our next session, we want to take a look at the primary and secondary DNS, which is a little different from our active directory integrated DNS zone that we would have looked at in previous lessons. This is the end of our session on the stub zone, and I want to thank you for listening.